Welcome to All This Math. This is Professor Parker, and today we're going to do a little work with the so-called Pythagorean Theorem. I call it so-called, as my students know that Pythagoras was a Greek that studied in ancient Kemet, now known as Egypt, and he studied and learned from our ancestors. But he is credited, and the Greeks are credited with discovering the fact that a squared plus b squared equals c squared, or if you have a triangle, a right triangle, with a 90-degree angle in it, if you take the square of one leg and the square of the other leg and you add them together, that will be equal to the hypotenuse, or the longest leg, or the longest side rather, of the triangle also squared. But I just wanted to put that out there. That's why I call it the so-called Pythagorean theorem. But anyway, before we do that, I do want to give a shout out to W.E.B. Du Bois and all the other people that graduated from Fisk University in Nashville, Tennessee. That was his undergraduate school where he was developed intellectually before going on to Harvard University. A lot of people give more credit to the fact that, or give more attention to the fact that he graduated from Harvard, but even he himself, I think, would give more credit to the fact that he graduated from Fisk University. So shout out to Fisk University, another HBCU, and support your HBCUs. At any rate, moving right along. Let's take a look at this short word problem that I actually assigned to some of my night school students, so they'll recognize this when they see it, even though I changed the name up. And what else did I change? I think that's it. I just changed the name. All right. I just, the name of the person in the problem, I changed it to Rashida. All right. So Rashida's TV is 20 inches long. If the diagonal measures 25 inches, how long is the width of her TV? All right. So this is a real life application, something we can think about. Now, it always helps to draw a picture. Drawing pictures, this is a geometry question, right? It always helps to draw a picture. So imagine a TV. TVs are shaped like rectangles, typically. All right, so draw your rectangular TV. Now, that TV is kind of small if it's only 20 inches long, but that's another story. We're just dealing with the mathematics, all right? So this is our TV, okay? Now, it also says that if the diagonal measures 25 inches, so we're going to draw a diagonal. Now, diagonal is a segment within a polygon that connects two non-consecutive vertices. So consecutive vertices would be this one and this one. All right. Non-consecutive would be like this one and this one. This one and then this one. Those are consecutive, right? If you were counting like 1, 2, 3, 4, this one and this one are non-consecutive. So by definition, a diagonal is a segment inside of a polygon that connects two non-consecutive vertices. So let's just draw a diagonal. There we go. That's our diagonal. Now, this is a rule that we need to understand. When we are dealing with a rectangle, when we draw a diagonal in a rectangle, a right triangle is created. A right triangle is created. That means that this is a right triangle and this is a right triangle. So that means that this is a 90-degree angle and this is a 90-degree angle. All right, now let's label some things. Let's label what we know. We know that her TV is 20 inches long. All right, so let's say this part right here is 20 inches. Right, and the diagonal is 25 inches. Right, from here to here is 25 inches. Now also, in terms of the right triangle, this side of the triangle is called the hypotenuse. The hypotenuse is the longest side of a right triangle. And it's also across from the right angle, right? This is the hypotenuse. Let me write that down. Hypotenuse. 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 All right? That's this right here. The longest side in a right triangle. Now, you can only have a hypotenuse in a right triangle. There aren't hypotenuses in non-right triangles, okay? Now, because we're trying to figure out what? How long is the width? We want to know this. So we're going to call that X. How wide is her TV? Now, when you see a right triangle and you're given information about two of the sides of the triangle, you know that you can use what I mentioned earlier, the so-called Pythagorean theorem. And this is the so-called Pythagorean theorem. A squared plus B squared equals C squared, right? A squared plus B squared is equal to C squared. So we have that. And now we basically just fill in the information that we know in the place of the A, the B, or the C, or, we fill in whatever we have. Now, there's going to be something that we don't know. We don't know one of these legs. Now, A and B in the Pythagorean theorem represent the two legs of the right triangle. So x and 20. Now, I'm gonna replace A with x. That's what I'm gonna do. And I'm gonna replace B with 20. Because A and B represent the legs of the right triangle. These are the legs. You have two legs and a hypotenuse. Two legs and a hypotenuse. All right. Now, somebody else might have made A 20 and B x. That would have been fine too. If you wrote 20 squared plus x squared, that would have been fine too. We will still end up with the same final answer. All right. Then you write your equal sign. And then C is always the hypotenuse. C is always the hypotenuse. Always. Hypotenuse, we know, is 25 inches. So you write your 25 over here, and that's also squared. All right. Now we're going to do a little bit of math, right? So now we simplify whatever we can. I can't simplify x squared because I don't know what x is. But I know what 20 is. I know this is a 20. 20 squared, I can do that. That's 400. Because 20 times 20 is 400. Now, keep in mind, 20 squared does not mean 20 times 2. It means 20 times itself, right? That's 20 squared. All right, 20 times 20. So I got two fingers up. I'm multiplying 20 is a factor 2 times in that expression. All right, same thing with 25. Over here, 25 squared is 25 times 25. That gives me 625. All right, then I bring down my plus sign and my x squared. Now, this is an equation. I'm trying to solve first for x squared. I want to isolate x squared on the left side of this equation. So what I want to do, I want to get rid of this 400. I want to get rid of this 400. I want to get rid of this 400. Now, how do I get rid of this 400? You do the opposite operation. This says plus 400. So the opposite of that is subtracting 400. Now, this is an equation. So if I do this on the left side, I need to also do this on the right side. So I do minus 400 on the right side also. Boom. Then I bring the x squared down. I bring the equal sign down. This is gone. This becomes 0. 400 minus 400 is 0. But I don't need to write plus 0. Over here, I do 625 minus 400, which is 225. So x squared equals 225, right? Now that I got x squared by itself, now I want to get x by itself. So what do I need to get rid of now? You guessed it. I need to get rid of this exponent. This exponent. Now, the opposite of squaring something is taking the square root of something. The opposite of squaring something is taking the square root of something. So that means I do this. The square root of x squared. And if I do it on the left side of the problem, I also need to do it on the right side of the problem. So I got to take the square root of 225. So this cancels out and becomes just x. And the square root of 225. And another thing, we should memorize all the perfect squares. Well, as many as you can, but I would say at a minimum, memorize the perfect squares from 1 through 25. Meaning 1 times 1 is 1. 2 times 2 is 4. 3 times 3 is 9. And so on, up to 25. So know what 1 times 1 is, up to 25 times 25. Try to memorize those. And if you had memorized those, we would also know that, conversely, the square root of 225 is 15. So if x is 15, that means that this is 15 inches, and it means that the width of her TV is 15 inches. And that's how you use the so-called Pythagorean theorem to figure out information about shapes that involve rectangles, diagonals, and right triangles that are created inside of them. All right. So, as usual, as I always say, please subscribe to the page if you haven't. Share this video. Tell some people about it. And as always, remember that there's all this math all around you.